Everyone work the problem. I brought the document camera. I thought, what a great opportunity. What we can do is I can grade some of them, and it doesn't count, but it gives you some idea of what's going to go on at the exam and after the exam. Has anyone done this ahead of time that we can look at? Oh my goodness, nothing. Nothing? No one? Who? Where? You did it ahead of time? You should. Can we grade yours? Okay, we won't embarrass you. You did it in red ink. That's interesting, because I have a grading pen in red ink. Okay, so let's take a look at this. I think this would be exciting. Yeah, why don't we try and do it? Except I don't know where it's going to go. My goodness. Okay, we don't need that. That was just the focus. I hope Mark's not here. He'd be. Well, that isn't going to help. Okay. How can I? We'll get this figured out someday. Oh, that's not bad. That's pretty good. Okay, so the question is, how do you make that a mean? Are there lots of ways of doing it? Take a look at that and see what you think. Does he have it correct? Does he have it correct? He said, I'm going to take cyclohexanone, add HCN, and then reduce the HCN with lithium aluminum hydride, followed by water to work it up. Does that look good to you guys? Anyone disagree? Anyone have another synthesis that's different? What can I do? I can't grade that. That's an A paper. Perfect. It's a perfect synthesis of that amine. Does anyone else have another synthesis of the amine? Yeah, good. Oh, I don't need that. You worked it out, or you want to work it by hand? I mean, who? Right here? Okay. Okay, I hope it's not right. We want, again, I'd like that one that's wrong so that we can discuss it. But let's see what we got here. Okay. Oh, that's the same thing. Yeah. You have one? How come? I put that on the website ahead of time. You can get 2 points if you turn it in today. 2 points to add to your clicker scores. Boy, this is a big failure, isn't it? Well, we can't waste time. Anyway, thank you very much. They were both correct. And here is yours. Save it, because you're going to get 2 points on that, okay? Okay, guys. Could you turn it back? Here we are. We're coming up on the exam tonight. Are you ready? Yes. Do you have another synthesis of that amine? Anything? Any other synthesis of that amine besides adding cyanide? What if that's not going to be one of the choices? Oh, you have another synthesis. You already have one. You have a second synthesis. What would you do?
I'm not sure exactly, but maybe you could do something with Grignard.
A Grignard. I agree. There is a reaction with a Grignard. You see, what we have to do is add 1 carbon. He added it with cyanide. He said, can we add it by a Grignard reaction? And the answer is yes, you could do that. The synthesis is a little longer, but can you have a good synthesis? And the answer is yes, you can have a good synthesis. He wants to add a Grignard. Any other suggestions? There are others. There are others. I like the Grignard. Okay, so let's just let's move forward, folks, because we got to finish this material today. So this is stuff that's going to be on the exam. This is all amine stuff. And so what do you think? Okay, what about that one? Is that one correct? For sure that's correct. I already gave it an A. So are any others correct? Are any others correct? What do you think? Make your choices. So you only have to look at these two. I've already told you. Only choose that one, D, E, or F. B and C aren't going to be correct. Any others look good? Okay, those of you who come to class on the day of the exam, the important thing is to exercise the brain, and this is good practice. Just think about this, get those neuronal connections being made to solve problems. There are going to be problems on the exam. Yeah, there's going to be some stuff. We can't get away from stuff. But there's going to be problems on the exam. And when you don't know the stuff, try and figure it out using what you do know. You'd be amazed how much stuff you know that you don't even know you know because you understand the fundamentals. What do you think? Which looks good? Oops, I don't have my device. Okay, let's get the old 10-second clock going here. See what we got. Okay. Okay, so the biggest answer is E. 1 and 3. Yeah, 3 was essentially his Grignard solution that he said. I didn't have a Grignard. I used an organolithium, but it's the same thing as a Grignard. It's the same kind of reaction. And I'm going to go through all 3 of these. But, of course, what was the correct answer? Do you remember back in the aldol chapter? In the aldol chapter, they talked that some of the problems use nitromethane. Doing aldol-like reactions. Nitromethane does an aldol kind of reaction. What happens is you generate a negative charge on this carbon here, and indeed that attacks the carbon of the carbonyl group. You make a nitro group, and the question is then, can you reduce the nitro group with hydrogen on palladium? Of course you can. So what was the correct answer? The correct answer was all of them. All of those 3 will indeed work. So you could have figured that, you were saying, well, I've never seen that guy there. That's why I think a lot of people left it out. But you could have figured it out, I do believe. So let's get rid of that guy. Let's go through this. So cyanide adds, and you already saw the answer he gave you. And then you get the cyanohydrin, and then we reduce it. Next one, we make the anion. This anion then attacks the carbonyl group, like so. You get a hydrogen on the oxygen, and so we move that guy forward to give this. And then finally, this one is the longest one, but nonetheless, I kind of like this one. The other ones would work as well. I like this one because it's got lots of chemistry we've done. Methyllithium attacks the carbonyl group, followed by hydrolysis. And then I stuck in heat. I just wanted to get a lot of stuff in there, so take up less space. The heat, what's that do? That does a dehydration. Acid under heating with a tertiary alcohol. Tertiary alcohols, very unstable with respect to heating because they got those tertiary carbocations they go through, very stable. You get the alkene. You add bromine and water, you get the bromine at that carbon atom and the hydroxyl group here. And then finally, you did azide on the bromide. And a number of you recognize that this would probably work. And you make the azide. This one you reduce with LAH, hydrogen, palladium, and that guy there. OK, any questions about that? Other syntheses? I'm sure there are. I thought 3 was enough to deal with. So one of the things with the amine chapters, there's a lot of different possibilities for making different things, different ways of making amines. Okay. Now, last time, and this is the last thing we'll talk about of material that could be on the exam, we discussed this particular reaction. You diazotize this, and it opened up to the 7-membered ring carbonyl group. Now, I didn't have a chance to really do the mechanism of that. And mechanism, those of you here today, the mechanisms are going to be stressed on this exam. I think there's 2 short answer written questions on mechanism, only 1 synthesis. And you always ask me, is spectroscopy going to be on the exam? A lot of spectroscopy in that chapter, but it won't be on the exam. What's the other question you always ask me? What's going to be on the exam? Okay. What are you?
Naming?
Naming, that's the other question I was thinking of. You know, I made up that exam a while ago, and I do not remember any explicit nomenclature questions. I hope I'm right on that. But if they are, you know, there was one initially. Oh, I better not say that. There was one initially, but I think I removed it. But now I'm not sure. This is what happens when you get a professor who's dealing with senility. He forgets these things. Hey, how about the mechanism? Let's do the mechanism. Now, you see an amino group with sodium nitrite. Sodium nitrite. You notice that's not sodium nitrate. It's NO2. And so this is a reduced form of nitrogen. It reacts with an amino group. And I went through the mechanism. I'm not going to do that again. It just goes directly, to the diazonium salt. These diazonium salts are very unstable when they're not attached to an aromatic ring. And so this actually, it doesn't require much warming at all. This diazonium salt is going to decompose. And what kind of a species is it going to decompose to? You told me last time, a carbocation, because it gives off N2 as a gas. N2 is a very stable molecule, and it's an excellent way to make carbocations. Now, the problem is it makes a primary carbocation, so you probably never really see it. The minute that carbocation starts to be formed, what happens is immediately that bond shifts right over like that. And so we break the bond between these 2 carbons, and we reform the bond between these 2 carbons. That's what opened us up to the 7-membered ring. And so that's the next step. It goes to give this carbocation, and let me just redraw that carbocation. These 2 are identical, to give you the 7-membered ring. And of course, the resonance structure of that carbocation is just simply the following, like so. And now I think you can appreciate that all this has to do is lose a proton, loses a simple proton to give you the carbonyl group. A mechanism question. Could have this one been on the exam? It was on an exam. If you look at some of the old exams, you'll see this actually was a question on one of the exams. So this is the level of the kind of stuff that you could have. Any questions about that mechanism? Any questions? You all see what's going on? Diazonium salts. Diazonium salts, think carbocation and nitrogen. What can carbocations do? React with nucleophiles, rearrange, undergo eliminations. And that's what it did here, of course, is it rearranged. Followed by, well, just rearranged. So, what do we have next? Well, that's the end of the material for the exam. We just finished off with that last problem. And now, you already asked me the questions of what's going to be on the exam. As I remember, if there's a nomenclature, it's short answers. There's no, geez, hey, a question about the exam. Free game. Anyway, you can ask me anything.
Are we going to have rearrangements, like the cope rearrangement and all that we did in the workshop?
Oh, yeah. That question's come up. You're the 4th person to ask me that today. I The cope rearrangement is in chapter 21, and we're not going to cover anything out of 21. Well, we actually are, but you had it earlier. In fact, we don't even finish the whole amine chapter. I left off the Hoffman elimination and a few reactions right at the end. We went up. It's on the website. Look at the website. We go to 20. So remember 20.10, and that's it. Only the beginning of the course to 20.10. So the cope won't be on there. The beginning. It's always the beginning of the course. It's what's so marvelous. It's hopelessly cumulative. Any other questions about the exam tonight? Look, you're here. You certainly. Oh, we have another question. Microphone. You microphone? No microphone. Where are the microphones? Okay. Okay. Yeah. Oh, I'm going to have to look at it. Like a problem. Yes. Okay. Good question. Good question. An extraction question. You know, of taking an amine, hydrocarbon, and a carboxylic acid, and going through an extraction procedure. I love that question because that is one of the more biologically relevant questions you could come across. Could that be on the exam? Yes, that could be on the exam. You better know that stuff. Good question. Any other questions? Okay, microphone again. Here we go. Who had the question? Third woman in there. Okay, your question is. To get turned on from the bottom.
Is benzene on the test?
Yell it in.
Is benzene on the test?
Benzene, of course. Is benzene on the exam? Did we discuss benzene in the lecture? We did. Now you're saying, but benzene, wasn't that in chapter 21? Yes, it was. But I discussed it in lecture in connection with diazonium salts. So can it be on the exam? Yes, it could be. Okay, any other questions? Well, let's. I've got a nice blank sheet so I can answer. Do you have any specific questions of things that are confusing to you? Something that's confusing? Because it's confusing you, it's probably confusing someone else too. So what is it? What is it?
Mine is on the mechanism for the Robinson annulation. It was a workshop, but it's not really like.
Oh, whoa. Robinson annulation. Robinson annulation, mechanism as well as knowing what the reaction is. In fact, I think the Robinson annulation is more interesting because you see a really interesting application of conjugate addition followed by an aldol. Can that be on the exam? Absolutely. Absolutely. Fair game. And it's in the book. The mechanism of that's in the book. It was on a workshop, but it's also in the book. Okay, well, let me bring up some problems we can do. What do we got next? Could that be on the next exam? Yeah, it could be. It's a problem in the book.
Professor?
We have a question. Great.
I have a question from the exam.
From an old exam. Okay, I got to look at it, unfortunately. Okay, let me just grab this. His question is, give the reactants in the following reaction sequence that would give the ketone shown below. Looks like a bunch of aldol stuff to me. Could that, yeah, of course that could be on there. You don't like it because it's bicyclic, but the answer is just simply yes, it's the aldol reaction. Or you had it as a Claisen. Either way, Claisen reaction, yeah, that certainly could be there. If that didn't answer your question, see me later. Anything else? Okay, how about this one? How about this one? Now, again, what is the lecture about? It's me trying to help you guys deal with a problem in organic chemistry, which I don't think are different than problems anywhere. Does this have a biological relevance? It turns out it does. The biological reducing agent, NADH, operates by a very similar mechanism. Very similar ideas are behind the biological reduction, NADH and NADPH. Both of those work in a similar way. Okay, so you look at that and you say, we've never seen this before. I can't figure out what's going on. Well, first of all, try, incidentally, you only see one aromatic ring here, and you see two there. Where's the second aromatic ring coming from? Where's the second aromatic ring coming from? Well, it obviously means that there's two of these guys involved. It's the only place it'd be coming from. Two of them are reacting. Okay. Anyone got a mechanism written down on a piece of paper? Thinking about it? Going through the brain? What in the world could be going on here? The key to problem solving in general is you've got to get started. Now, your first start might be a false start. And when you have a false start, you go back to the beginning. You try a different start. So don't shy away from something that you haven't seen before. I believe everyone in this room knows the first step. You may know more than one first step, but you know at least one first step. So let's say microphone. Here's what I'm going to ask. And let me ask again. We were working on the second row from the back last time. That looks like a new cast of characters there. Which one? Well, we've done him before. So how about some of those guys? Who would like to? Here's the question. Is hydroxide an acid or a base? Who would like to answer that? Yeah, lots of hands.
It's a base.
It's a base. So therefore, if it's going to react with this, is this going to be an acid or a base?
Acid.
It's going to be an acid. Next question. Where on this molecule are the atoms that are going to behave as an acid or a base? I will number them. A, B.
B.
Well, that was easy. He's correct. It is going to be B. Any others? Any other atoms behave? You're absolutely correct. It is B. Can you see any other atoms that can accept a pair of electrons?
No.
You did well. You did well.
No.
Okay. Excellent. He said that hydroxide ion is going to attack that carbonyl. What's the first intermediate? Are you going to go along with him, or are you going to go along with the second thing of where you remove a proton? In other words, I had this proton accept a pair of electrons, but I did is exactly what he did. Now look, we need to get the mechanism. You don't know the mechanism yet, but you got to start. You got to start with, see, the problem is when you try and work the stuff out in your head, you try and solve the whole problem. And what if you can't solve the whole problem in your head? So you start. And by going one step, taking little chunks, you keep reducing the complexity of the problem into, it's a big problem to begin with, but once we do a little bit of it, what remains is going to be smaller. So let's do that. A or B? A or B? What I would go, always in a mechanism, I do what's most logical first. Now, if that doesn't work, you've got to do the next most logical thing. What makes the most sense to do as a first step? Remove a proton or attack the carbonyl? Which do you think? So, how are we doing? Well, that's not bad for a Wednesday before the exam. Poor folks at home studying. You people have confidence. I want good answers. I know this is my better group. So you have confidence about tonight's exam. You said, look, I'm going to go to lecture, see what we can find out. And here you are. Okay, let's do the 10-second clock. See what we get. A or B? And the answer is most people, what the gentleman told us in the back, most people like A. He gave a convincing, he had a lot of confidence, I noticed, but he said attack the carbonyl group. Okay, what is the correct answer? It turns out the correct answer is A. Excellent, excellent. So obviously that's going to happen a lot. Now, is that anion very stable? Is that a stable anion? Now, you know anions alpha to a carbonyl, adjacent to a carbonyl. You know that an anion adjacent to the carbonyl group is stable because we can delocalize the negative charge out onto the more electronegative oxygen. But how would you possibly get this negative charge onto that oxygen? The only way you can do it is by breaking a bond. And that's the problem with that is that's not going to be very favorable. You can do that. You can move that pair, and that'll put a negative charge on the oxygen. This carbon goes neutral, but how many electrons would that carbon have? Only 6. Right now it's got 8. It'd have only 6. And so the bottom line is that you can't get the negative charge onto the oxygen using a stable electronic configuration or resonance structure. Okay, so that's a terrible anion, absolutely. And let me erase that thing, lest someone write it down. So it does that as a first step. So let's see where we can go, with it. So where OH attacks this guy. Now, look, we got a long ways to go. I've just attacked the OH. What is the most probable thing that's going to happen? We took an aldehyde, we attacked the OH, and now we know we're going to want to reform. We're going to want to reform this carbonyl group, right? Because we've seen that happen over and over again. You can see that you can see the carbonyl group there. So we know that we want to reform this carbonyl group. What is the most logical thing that's going to happen? We're going to break a bond. But which bond are we going to break? Are we going to break the bond to the oxygen? We're going to move that pair of electrons out onto the oxygen, out onto the hydrogen, or out onto the carbon. Why don't we go back to our row again? We got the microphone there. We got this guy. Why don't we go to, yeah, hey, you got a good team here. They're going to give you good support. We need a good leaving group. Which of these is going to take the negative charge? OH, hydrogen, or carbon? Oxygen, hydrogen, or carbon? Who's going to walk away with the negative charge that comes from these electrons?
OH.
OH, that's correct. That is the most probable thing to happen is to just kick off the OH and go backwards to give us the carbonyl group and the hydroxyl. What are the chances are that that is going to be an intermediate in our mechanism? Oh, let me ask you that. Is that going to be an intermediate in our mechanism? Yes or no?
Yeah. No.
Consult. You don't just jump out. You got a crowd here.
I think yes.
Okay. Is it going to be an intermediate in the mechanism? Yes or no? Think about it, everyone. Yes or no? Well, you got to say something. Guess.
No.
Hey, is that correct? Yes. Is correct. The answer was no. It's not going because it just takes us back. So something else is happening, and you know that something else is happening. Look, we got a carboxylate and an alcohol, and we started with an aldehyde. So, and we also got to involve another one of these. So let me just bring one of those guys down. Let's just bring it down. I'll bring it down like this. I put it here for a reason. And we already said that we're going to want to reform that carbonyl group. Is there something else that could happen here? Hey, looks like we could form a hydrogen bond. So let's put in a hydrogen bond there. Okay, now I have set things up And I can give you the answer, and I will give you the answer. But can you come up with the proper curved arrows that are going to go from this structure to another structure I've got over here, and ultimately up to the final product? Can you guys come up with those curved arrows in your heads if you don't have a piece of paper? Or if you've got a piece of paper, you can write them down on a piece of paper. Like these guys over here, they do everything in their head. Okay. This is going to be one of our curved arrows. Where do you think the next curved arrow is going to be? Anyone want to tell me the mechanism? Ah, boy, you are a multi-threat guy here today. Okay, we need some other curved arrows. Where are they going to be? And you actually have it. Boy, yeah, excellent, excellent. He's got it completely correct. Now, he didn't use words, but he's got it completely correct. Everyone figured this out already? How about the front row group? Michael, we good on this? Yeah. Okay. Well, I guess you guys, can you see the next arrows? Yeah, not sure. I think that's maybe my. Did you put it on a piece of paper? I could put it. Yeah. Okay. Let's look at this guy. This is an alcohol. This is an aldehyde. When we go from the aldehyde to the alcohol, is that an oxidation or reduction? It's a reduction, right? How would we do that using reagents you know about? What kind of a reagent would convert an aldehyde to the alcohol? That I can get from someone. What kind of reagent, aldehyde to an alcohol? Okay, you want to try that one?
NaBH4.
Sodium borohydride, or hydride, H minus with 2 electrons, okay? That's the key. We need an H minus. We need a hydrogen to attack that carbon with its electrons. And so that's it. That's what we do. These electrons attack, like so. This pair of electrons, I guess, would reach out like so. And this pair of electrons would move out on to that oxygen. You know, actually, I don't think, but that would work. So we, into there, hydride. You notice that's not H plus. That's H with its 2 electrons. So it's H minus. That's why it's like NADH in biology. A very similar process is occurring in your liver as you sit here. You are transferring hydrogens with their electrons to carbonyl groups as we sit here. So, and what's that give? I actually don't think, yeah, I actually didn't do exactly that. I didn't do this one. I did them both. And then that just goes up to there. What I could have done is just gone directly. In fact, let me just show you. And you guys do this all the time on the exams. Oh, yeah, there it is. Those 4 arrows will go up there. And if I didn't put this arrow, we would have gone over here and then up there. Either way, 2 ways of getting the arrows in. Personally, I like multiple structures because it makes it a little easier to grade. These things with zillions of arrows on them. And it's also easy to make a mistake when you start putting a lot of arrows. So on the exam, think about your mechanism. Remember, the exam is going to have space for you to write stuff down. Once you get it down, you think it's correct. Carefully write it on the answer sheet. Be very careful on that, because so many of you come to me and you show me you got the right answer, but you transferred it incorrectly. So watch that. Don't get lulled into complacency and mess that one up. Any questions? This is called the Cannizzaro reaction. It's been known for a number of years. Any questions about it?
I got a question.
Ask a question. We don't need. It's in the balcony? Yeah, hey, good.
Is there going to be a Kurdish rearrangement on the test?
It's not quite on topic. Well, other than the exam.
Why not?
No, of course we can discuss that. Courteous rearrangement. Oh, is there one on the exam? I don't remember if there's one on the exam. Could there be one on the exam? Has there been one on other exams? Yes. Know what the courteous rearrangement is.
Yeah, but do we need to know it for this exam?
Well, what can I say? Good question, wasn't it? Might as well try. Okay, let's do another problem. Have we done this one before? Does that look familiar to you? This could be, I say, what is the mechanism? I could ask you, what is the product? When you mix these two together, could you write down the product for the question mark? What kind of a reaction do you think this is going to be? Well, we're treating it with base. We're treating it with ethoxide. We're going to remove a proton. Which of these two compounds is more acidic? Is it A or is it B? Okay, if this were an ester and a ketone, which one would be more acidic? Who wants to? Good. Which one would be more acidic?
B.
B would be more acidic, the ketone. You're right. However, it's a bromoester. Is the bromine going to enhance the acidity or decrease the acidity of its alpha hydrogen? Enhance or decrease? Bromine.
Enhance.
Enhance the acidity. So the answer to that question, which one is more acidic, I don't know. I don't know which one it would be because the bromine is going to enhance the acidity. But would that stop me from writing down products? No, I just go ahead. If I pull off that hydrogen and attack that carbonyl group, I get one product. If I pull off that hydrogen and attack that carbonyl, I get another. Would they both, at this level of knowledge, be correct? Yes, they're both correct. I don't know which one it would be. However, I'm going to give you the product, and I want you to come up with a mechanism. Whoops. Jeez. My brain is... There's the product. What is the mechanism for that reaction? You say, wait a minute. Wait a minute. That doesn't make any sense. What is the mechanism of that particular reaction? Well, let me ask you. In the mechanism, are you going to have anion derived from A or anion derived from B? In the actual mechanism, are you going to have anion derived from A or anion derived from B? How about the next to last row? How are we doing? Anyone? These are hard questions now. Is the anion going to be derived from A or B? Yay, we got a volunteer. Microphone over to that guy. And you get 2 points added to your clicker score no matter what. Which one?
A.
Yeah, he says the anion is this guy attacking the carbonyl of that. He's absolutely correct. There it is, that anion, and then he said that anion is then going to attack that carbonyl group like so, and it goes out onto here. This is called Darzin's condensation, and the result of that is going to be, shown here. What is the next step? How is it? Let me get rid of some of this stuff. How is it that I go down to this final product? How is it I take that to that? You have an idea? Tell me your idea.
The negative oxygen make an SN2 and kick out the liquid leaving group.
Exactly. SN2 reaction, you make an epoxide. Exactly what's going to happen. So this guy, the negative charge here, pair of electrons swings in, kicks out the bromine. Okay. Now, what's next? So we did the mechanism. Let's do another mechanism. What is the mechanism of this reaction? What is the mechanism of this reaction? That is, if you take this ester, you treat it with hydroxide ion. This is probably in water. You get this aldehyde. Can you do this guy? Well, when you treat an ester with hydroxide ion in water, what do you get? Hydroxide ion, we already have established, is a base. So that must mean this is the acid. So which of these atoms, which of these, I'll say, carbon atoms, which of these carbon atoms, you've got a lot of carbon atoms, which of those carbon atoms is acting as the electron acceptor? How about, you got the microphone? How about that guy? You help him now. Don't leave him abandoned. He's good with it?
Yeah.
Okay. Which atom is going to be the acceptor of the pair of electrons? This one?
The carbonyl, the carbon that's holding the epoxide, the lower degree.
Okay. Does that make sense? Yes, that would make sense. What he said is that the hydroxide ion could come over there, or it could come down to here. Those are two possibilities. Those are two possibilities. Give me a third.
The carbonyl.
Exactly. Or the carbonyl. Are there any others? No. None. There are no other reasonable possibilities. Those are all good. And if you're working on a mechanism, on a sheet of paper that's not your answer sheet, write all three down and see if any of them look good to you. Now, do you notice, you gotta look here. What do we have? You count up our carbon atoms. 1, 2, 3, 4, 5. Forget the ester. 1, 2, 3, 4. This carbon atom is lost. That carbon atom is lost. So that's something to keep in mind in your mechanism. A lot of stuff is going. This isn't just going to be simple. We're not going to be able to just attack this in one step and end up with this. It's going to be more than one step. Okay, let me tell you what happens first. I'm just going to put down what happens. You could go through those others that he suggested, but what I am going to do is hydrolyze the ester to the salt. So we have the oxygen attack the carbon of the carbonyl. This swings back, kicks out ethoxide, and we get the carboxylic acid. And the carboxylic acid, of course, reacts with ethoxide. Ethoxide just swings down here, much stronger base, plucks off that hydrogen, and what do you get? You get this guy here. Now, this is a key intermediate. So simple hydrolysis of that ester, which you all know about, simple hydrolysis of that ester gets you to a really key intermediate. Because in very few arrows, in fact, some of you who can accurately show multiple arrows could actually go directly from this structure, down to this compound here. You indeed could do that, but it wouldn't be easy. What I would do is the following. I move this pair of electrons into there. Now I'm going to get off carbon dioxide. So that's how we lost that carbon. We're going to lose it as carbon dioxide. And to get carbon dioxide, I have to take this pair of electrons, and I have that pair of electrons right here in that bond. The problem is I got to move those electrons to some place where they're going to be more stable. And this is the challenge. This is by far the hardest step in this mechanism. And so which of these atoms? I've got 1, 2, 3, 4. I got 4 carbon atoms and an oxygen. Where do I want to put the electrons? Where do I want to put the negative charge? Do I want to put it onto one of the carbon atoms or onto the oxygen? How about you? Carbon atoms or the oxygen?
Carbon.
Carbon. Second choice?
Oxygen.
Why the oxygen?
Because you want a double bond on it?
No, the oxygen because more electronegative. Oxygen wants a negative charge. You know all this stuff. I got you all flustered. I know that. Okay, so I want to move that pair of electrons out into the oxygen. And she's saying, that's ridiculous. How can you possibly do that? Well, watch this. I'm going to take that pair of electrons, and I'm going to move it into there to form a double bond. Well, you say, look, if you're going to form a double bond, you have to have a leaving group. Guess what my leaving group is? Right there. How's that? I know, you said, that looks really weird. Could you write down on a piece of paper the product of that particular reaction? Could you write down on a piece of paper the product of that particular reaction. It is the enolate, and then the enolate converts to the enol. We're good on that?
No.
Okay. Practice your mechanisms. As I said, there's one synthesis and at least two mechanisms. Maybe more. Maybe more. Mechanism is the foundation of chemistry and biology. Understanding how the electrons behave helps you understand how life works. Okay, well, I think we'll call it quits. But this guy wanted to make an announcement. Let me give you the microphone. He wants to sell you some tickets if you guys are willing to pay. Here you go.
Okay. Hey, what's